Alright, good day viewers. Today we'll be talking about compound angle identities. Now, this being our fourth class on trigonometry, you have to go through the previous sections of these trigonometry videos to have proper understanding on what we are doing today. Now, for compound angle identities, this is when we have the trig ratios to be expressed with respect to the sum of two angles. Now, to better express this mathematically, if we have a plus b and we are to find the trigonometric identity for this of a plus b, let's say for sine, for cos, or for tan, we must be able to express this properly. Now, what do we do for compound angle identities? Should we have sine a plus b? Now, to be able to do this, it would be wrong to express this using the normal distributive property in algebra. That is, if this is sine A plus sine B, it will be very wrong to say this is correct. Because if I were to express any trigonometric function this way, it will be definitely wrong. So what do we do to express this? We say sine A plus B will definitely give us sine A cos B plus sine B cos A. So this is how the distribution is done for trigonometric identities under compound angle identities. Alright, so if we are having the subtraction of this, it gives us sine A minus B. This is equal to sine A cos B minus sine B cos A. Now, how do we do for cos? Now, there are certain things that cos has that is peculiar to it, because cos is actually cosine, and cosine means complement of sine. And so if I read that, this gives us cos A plus B, and this will be cos A cos B minus sine A sine B. So, unlike the sine, cos is actually a very jealous trigonometric ratio. So let's do for subtraction. Cos A minus B is equal to cos A cos B plus sine A sine B. So this is how to express the compound angle identities for sine and cos. Now, if we are asked to find sine 15 without using a calculator, how then do we do this? Sine 15 degrees. Sine 15 degrees, we have to now go and pick our acute angles that we know from trigonometry. That is, sine 15 is equal to sine 45 degrees minus 30 degrees. Because we know that 45 minus 30 gives us 15 degrees. Now, so 15 degrees can be expressed as 45 degrees minus 30 degrees. Now, using this compound angle identity we have here, we will expand this the same way we did here. So this gives us sine 45 degrees cos 30 degrees minus sine 30 degrees cos 45 degrees. Now, since these are acute angles the proofs have been made already that sine 45 is the same thing as root 2 over 2. Cos 30 is the same thing as root 3 over 2. Sine 30 is the same thing as 1 over 2. And cos 45 is the same thing as root 2 over 2. So this gives us root 2 times root 3 is root 6. 2 times 2 is 4. Minus 1 times root 2 is root 2 over 2 times 2 is 4. Now, because both of them have the same denominators, we can join them to say this is root 6 minus root 2 divided by 4. So this is how to express compound angle identities for trigonometry. So this is the fourth class of trigonometry where we are talking about compound angle identities. Don't forget to like, share, and subscribe. Bye for now.